Welcome back. In this video, we are going to learn how to read SQL Server Execution Plans like a professional. Many developers execute queries, but they never look at the execution plan. As a result, they don't know whether SQL Server is using indexes efficiently or scanning the entire table. We will also optimize our query and compare the execution plan before and after adding an index. Let's assume our transaction table contains around 2 million rows. The clustered primary key is transaction ID, which means the table is physically stored in the order of transaction ID. Notice we do not have an index on branch ID. That small detail is going to make a big difference when SQL Server executes our query. Now we enable an statistics. Before running the query, let's enable some useful statistics. Set statistics IO on. Next, set statistics time on. Go. These commands don't change the query. They simply tell SQL Server to show us extra performance information after execution. Statistics IO tells us how many pages SQL Server had to read from memory. Statistics time shows the CPU time and the total execution time. We will compare these values before and after optimization. But before running execution, we should enable include actual execution plan. We enable this and then run our query. Our query transaction table is one of many other tables in our database, inventory database, and we are queuing just some of our columns like transaction ID, account ID, employee ID, branch ID, transaction date, amount, transaction type. In this query we are using where branch ID is 5. Branch ID has no index. So now we are ready. Execute the query. After execution, SQL Server generates an execution plan that shows exactly how it processed this request. What is an execution plan? Think of the execution plan as SQL Server's roadmap. Instead of simply giving us the results, SQL Server also explains how it found these results. It tells us which indexes were used, which operators were executed, how many rows were processed, how much work SQL Server had to perform. Let's start reading it. Operator type. The first thing I always check is the operator type. In our case, SQL Server is using a clustered index scan. A scan means SQL Server is reading the clustered index, one row at a time, searching for rows where branch ID equals 5. Now remember something important. A scan is not always bad. If your query needs almost every row in the table, scanning is often the fastest option. However, our query only needs one branch, so reading the entire table is unnecessary work. Whenever you read an execution plan, always ask yourself, is SQL Server scanning the data or is it seeking directly to it? Factor number 2, predicate. Next, let's open the properties window and look for the predicate. Here we can see branch ID is 5. Predicate tells SQL Server exactly which rows we are looking for. Now ask yourself one simple question. Does branch ID have an index? In our example, it doesn't, because there's no index starting with branch ID. SQL Server has no shortcut. It has no choice except to scan through the table until it finds every matching row. Whenever you see the whenever you see the predicate, identify the filtering column and ask whether that column is indexed. Factor number 3, clustered index with non-clustered index. Let's quickly understand the difference. A cluster index is the actual table. The rows are physically stored in the order of the clustered key. In our table, there's transaction ID. A non-clustered index is different. Think of it like the index at the back of a book. It stores the indexed column together with a pointer to the actual row. If we had created a non-clustered index on branch ID, SQL Server could jump directly to the branch ID equals 5 instead of reading the entire table. Factor number 4, estimated rows with actual rows. Now let's compare estimated rows and actual rows. Estimated rows are SQL Server's prediction before executing the query. Actual rows are what really happened during execution. If these numbers are very close, that's good sign. It means SQL Server's statistics are accurate and the optimizer made a good estimate. If they are very different, SQL Server may choose an inefficient execution plan. Whenever you need an execution plan, always compare these two values. Execution factor number 5, actual rows read. This is one of the most important properties in an execution plan. Execution rows tells us how many rows were returned. Ex- Actual rows read actual rows read tells us how many rows SQL Server actually examined. For example, SQL Server may return 20,000 rows but read 2 million rows to find them. That means a huge amount of unnecessary work was performed. Whenever execution rows read is much larger than actual rows, is often a sign that a better index is needed. Factor number 6, index seek with index scan. Now let's understand the difference between a seek and an scan. An index seek means SQL Server navigates directly to the matching rows. It doesn't waste time reading unrelated data. An index scan means SQL Server reads the entire index from beginning to end. Even though an index scan reads everything, is still usually faster than a clustered index scan because indexes contain fewer columns and therefore less data. As a general rule, if your query returns only a small percentage of rows, SQL Server should ideally perform an index seek. Get percentage. Factor number 7, cost. Factor number 7, cost percentage. Many beginners immediately look at the cost percentage, whereas professionals usually ignore it. These percentages are only optimizer estimates. They do not represent actual execution time. Instead, focus on operators, row counts, and logical rates. Those tell you much more about query performance. Factor number 8, number of executions. Next, check the number of executions. Sometimes an operator is inexpensive by itself, but if a SQL Server executes it thousands of times inside a loop, the total cost becomes very high. Always check how many times an operator ran. Factor number 9, estimated row size and execution mode. Estimated row size tells us approximately how much memory each row requires. Larger rows require more memory and can increase memory grants. Also notice the execution mode. Most OLTP queries use row mode. Analytical queries may use batch mode, which processes many rows together and is generally much faster. Factor number 10, statistics IO and statistics time. Now let's switch to the message tab. Statistics IO shows the logical reads. Logical reads represent how many data pages SQL Server had to read. In most cases, fewer logical reads mean a more efficient query. Statistics time shows CPU time and elapsed time. CPU time is the amount of processor time used. Estimated elapsed time is the total time query took from start to finish. These numbers are these numbers are excellent for comparing performance before and after optimization. Factor number 11, warnings. Finally, always check for warning icons in the execution plan. One common warning is a missing index recommendation. SQL Server is basically saying if you create this index, this query could run much faster. Don't create every suggested index, but always review these recommendations. Optimize the let's optimize the query. Now let's improve our query by creating an index. Now execute the same query again after creating index. We immediately notice the difference. Instead of clustered index scan, SQL Server now performs an index seek. You will also notice fewer logical reads, lower CPU times, and a shorter execution time. The query is doing much less work because SQL Server can jump directly to the reads, rows, rows it needs. Let's conclude our discussion. Whenever you are analyzing an execution plan, follow this checklist. Check the operator type. Is it scan or seek? Look at the predicate. Which column is filtering the data? Compare estimated rows with actual rows. Compare actual rows with the actual rows read. Check whether SQL Server is using the correct index. Review logical reads and CPU time. Finally, look for warnings like missing index recommendations. If you follow these steps every time, you will quickly become much better at identifying performance problems and writing efficient SQL queries. Thank you very much. Bye.